Okay, hello everyone. This is video 2-18 for Tuesday 10/25. The corresponding homework is page 28, numbers 1 and 2, just two problems. And here is the first example. We're going to take the derivative of this function. You'll have to write it in. So take a moment to write that in. If I go too fast, just pause it. But there's the function we're taking the derivative of. Now, I don't know that this is necessary for everyone. So I'm going to get going, guys, but pause this if you are writing that down still. I am going to first write the function again with arctan in different notation, and the only reason I am doing this is in case it helps someone, because if we're used to seeing it, like in all your years of math before this, you've seen the inverse trig functions written in this type of notation. So rewrite it if it helps you. You can just leave it like that if it doesn't, or if it doesn't make any difference to you. So there's that. Now, I have to ask myself, how am I going to take the derivative of this? What rules are involved? Well, I see a term that looks of the form ax to the n, so I know I'll be using the power rule. I see the inverse tangent function, so I know that I'm going to be using the, I'm flipping a page, I know that I'll be using these formulas from yesterday's lesson, or one of them. And then I see inside of inverse tangent not just x, but another function, the square root of 5x. And then if I just focus on the square root of 5x, that also is a function within another function. So definitely chain rule involved. Oh, but then also, guys, this is a product of two functions, so the product rule involved. Now, I'm going to write some exercises for you guys soon where you have to say what rules are involved before you use them, because I think that'll be valuable. So why don't I just say that right now? I know I'm going to use the product rule. I know that within the product rule, I'm going to be using the power rule, inverse trig formula, and inverse trig formula, and chain rule. So in order to take this derivative, I really have to put together these four techniques here. Okay, so I'm going to use brackets for the product rule. Okay, so y prime is going to be, okay, so I've got blank prime, blank, plus blank, blank prime. Okay. And so this one's going to be 1/3 x to the 9th, inverse tan, I made these too small, square root of 5x, 1/3 x to the 9th, inverse tangent, radical 5x. Okay. So, let's see. Okay, I guess the order I'm going to do this in, so first I'm going to look at the brackets I'm taking the derivative of what's inside with. And I see that this is the one that involves chain rule, so I know I'm going to use in and out charts. So I'm just going to focus on this for a moment. And so this here, I not only have one function inside of inverse tangent, but I have two functions inside of inverse tangent. If I look at it that way. I'm making this video at 5 in the morning, guys. Sorry if I'm slow. Okay, so the innermost function is 5x. That is inside of blank to the 1/2. And then they're both inside of inverse tangent blank. Okay? I'm going to have to, and guys, I don't even know the formula for this right now. Every time we do this unit, I have to re-memorize them. So off to the side, I'm looking at my formulas. Okay, so the derivative of this first part is just 5. The derivative of this is 1/2 blank to the negative 1/2, 5x going back in. And then the derivative of this, I'm looking at my formula sheet, inverse tangent, is 1/1 plus blank squared. Okay, and what goes back in the blank are the old insides. So I have blank to the 1/2 goes back in. Okay, I'm going to write it as radical. And 5x goes back in. So just like that. Okay, so now I'm going to do the rest of the problem. Yeah. Okay, yeah, now I'm going to do the rest of the problem. So let me bring this all down in one line, because the other derivative that I have to take is not so complicated. So let me bring it all down here. So we've got y prime, and I'm not even going to simplify. Y prime is equal to the derivative of this. I'm using power rule there, and I end up with 3 x to the 8th, okay? And then this one just comes down times inverse tangent radical 5x. This one, so I bring down the plus sign. This one just comes down 1/3 x to the 9th. And then I've got my derivative here. Okay, so this is, maybe I'll clean it up a little bit, but you don't even have to. So this is going to be multiplied by 5x to the negative 1/2 all over 2, and then this is 1 plus 5x. Okay, I'm just going to make that observation, guys, that this radical squared, I would just end up getting the input. Okay, so there's that. That's a mess. Okay, and really, guys, taking derivatives does not get harder than this. Double chain rule with all this stuff, it's not going to get harder taking derivatives. So here we go with a second one. Now this one here, I see a -10 multiplied by the inverse cosecant function. Guys, this is not product rule. This is just a coefficient on the function. So think of it as like part of the function. You would just carry it down and then take the derivative of inverse cosecant. So this is not a product rule situation. Now, same as before, I'm going to say like stuff that I see. I see, okay, so I see that I will need an inverse trig formula. I do see a polynomial here. I do see something with terms of ax to the n. So I know that I will need power rule. And then I do see functions within functions. I see 5x to the 5th minus 7x underneath this cubed root, which is also inside of the inverse cosecant function. So this is definitely chain rule, double chain rule to be exact. So yeah, all I need, there's no product rule or quotient rule here. So I'm just going to go right to the in and out chart here. The innermost function is 5x to the 5th minus 7x. That is inside of blank to the 1/3, which is inside of -10 inverse cosecant of blank. Derivative of this one is 25x to the 4th minus 7. The derivative of this one is 1/3 blank to the -2/3, I think, because 1/3 minus 3/3, yes. And then, like I said before, I'll just do parentheses here. I'm bringing down the -10 times the derivative of inverse cosecant, and I'm looking at my chart, which I have off to the side with all the formulas. The inverse cosecant formula goes like this. Negative is kind of complicated. -1 over, you don't need these parentheses inside, but absolute value of blank, and then big square root blank squared minus 1. I'm going to email someone from the workshop I went to, guys, and just ask her, she's a woman I really trust, if she has her students memorize even the inverse cosecant and inverse secant ones. I'm pretty sure she said she did, but it's kind of complicated. It's really complicated, and it doesn't show up quite often. So, okay, so what goes back into these things? This goes back in there. So 5x to the 5th minus 7x. And then, guys, there's two blanks here. I had one blank in the, before I took the derivative, and now I've got 2, but that doesn't matter. It doesn't matter if I have 5 blanks once I take the derivative of something. That would never happen, but what goes back in is what was in there before. So this is going to be 5x to the 5th minus 7x to the 1/3. I'll make that look nicer later. And then this is 5x to the 5th minus 7x to the 1/3. Hi, Loz. Okay, and then I'll just make this look a little bit nicer. Y prime equals, oh boy, I'm not even going to do much at all. I'm just going to write it clearer. So this is 25x to the 4th minus 7 times 1/3, 5x to the 5th minus 7x to the negative 2/3. Yeah, I'll just make that a positive 10. What a mess. And then this is 5x to the 5th minus 7x. Oh crap, you can't even see what I'm doing. Sorry. 5x to the 5th minus 7x to the 1/3. Close the absolute values. And then this is, I'll just change the 1/3 to the second to 2/3 so I don't have to use so many parentheses. And then this is 5x to the 5th minus 7x to the 2/3. If that doesn't make sense, guys, think about that. Oh my gosh. Okay. Yeah, so derivatives that ugly really won't even show up that much, guys, but we do have to know how to do them. So there's that, and I will see you soon. Bye-bye.